So we're now going to spend maybe the next 20 to 30 minutes, which I believe could be the most valuable 20 to 30 minutes, or at the top short list of all the things you've learned in all your schooling. Because this is exactly how, this is the engine. This is the little spark plug in the center of the engine that lets us go from a statement or a description of a problem to working code. And this would work for database or programming as well. So I think there's a lot here, but there are some requirements on you. You have to use your imagination. You have to think you're like somebody who's writing a story. And sometimes we have students who are, maybe they're in a business technology program, but they're also like with a strong background in writing, especially writing fiction, and they're used to using their imagination, and they have a much easier time of it. So let's try and get all that going now. So requirement 1, I have actors, and I don't really consider actors as nouns because actors are outside the system, right? Remember that. Sometimes students get a little confused and they say, well, isn't an actor a thing? And then you have to be like a lawyer and you have to remember what's the definition of an actor. An actor is something external to the system that initiates action and performs value, or it receives value back. So an actor cannot be a noun. Recording the collection of payment. Well, payment is definitely a noun, and recording is definitely a verb. So we're making out well. So far, we've already got a couple of things. Now, is recording necessarily the best word to use? That was what our business user told us. I don't think it's necessarily the right thing in this context, but we can go and fix that up in a minute. The system shall provide a user interface. Oh, interesting. Requirement 1. So now I'm looking at my user stories and my requirements and my use cases. I'm looking at all three things. And it's awkward here because I'm trying to keep everything on the screen at the same time. And I also have use case scenarios in my LaTeX document, so I guess I need to go and look there as well. So let's flip over to LaTeX. The clerk scans all the customer purchases. All right, so that's from requirement 1. Let's bring this over to here for convenience. So I have product, and what's a product? Well, it's ultimately going to become a UML entity, right? Because in terms of design pattern, in terms of mediation of my database, a product is going to have many attributes, the type of product, purse, jacket, scarf, wallet, and it's going to have a color and a size and a bunch of other stuff. But for right now, it's enough to know that a product is a verb and a payment is a verb, and a customer is an actor, but a customer is also a noun. But Peter, you just told us an actor can't be a noun. Sorry, you can't. That's why this is a little bit tricky. Perhaps a very easy heuristic, a mental thinking rule here is, do I need to model this entity, this thing in my system? And yes, I definitely need to model a customer. I'm just going back to the camera because it feels like I'm talking to the class and it's psychologically easier for me. Do I need to model a customer? And the answer is yes, because a customer has a cell phone and they have a credit card number and they have a purchase history and they potentially are somebody I want to send marketing emails to in the future to get them to come and buy more stuff. So I will model anything that I need to create an artifact for in my system. Do I need to model a sales clerk? And the answer is no. A sales clerk is an actor. They're the ones activating the cash register and scanning and thanking the customer and saying, were you happy at our store today? But we don't actually need to model a sales clerk as a database record or as a class. But we do need to model a customer, and we need to model a purchase, and we need to model a payment, and we need to model a transaction. And I can rhyme those things off because I've done this a billion times. If you're experiencing some difficulty or frustration, my advice is do not get frustrated. Treat it like a game, right? Just treat it like a play, like children playing, with some, I don't know, like the whatever it is kids play these days. So just imagine that you're playing make-believe and you're seeing if it works, then do it, and if it doesn't work, then go and do something else. So I need to model a payment and a product and a customer. Do I need to model anything else? Well, payment, product, customer, and verb, what action do I need to do? Let's call it log, because logging is more of a thing that we talk about in IT. So we have to log payment, and specifically we have to log several factors, right? Now we're going to talk about attributes. So in addition to nouns, we have another thing here, which is the detail of the nouns, which is attributes. So we have to log payment, which includes kind of payment, cash, Visa, MasterCard, gift card, kind of payment. So we have a product. And we have a customer buying the product. And we have a payment method, which has some attributes such as kind of payment, amount of payment. Now, Mary, does the payment belong to the product or the customer? Mary, does the payment belong to the product or the customer? It's a trick question. Let's see if we can fool her. Well, so you're telling me that the product does not have a price. That's what you're saying. So we're giving our product away for free? She actually gave the right answer, which is both. She said product and customer, and yes. And when we have an entity which connects to other entities, what's that called? I said when we have an entity that connects to other things, what's that called? Think about the relational database system. It's a relationship. It's a relationship. Yeah, exactly. It's a relationship. That's right. So here, my payment belongs to both of these because the customer is doing the payment, but the product has a price and the store is collecting the payment, right? And we're modeling the store as the cash register, really, right? Agree or disagree? For the sake of our business domain analysis, the store, what is the store exactly? I would argue that the store is the cash register. The cash register is the artifact in our system which is modeling the store. So a product has a price. So in a sense, you could see the product needs a payment. Guys, do you understand? Am I starting to get across to you thinking in abstractions? So it needs payment to match that price. If the bicycle costs $200 and if I pay $300, the clerk's going to go, well, wait a minute, I have to give you your change because the product's only $200. And the customer here makes the payment. And guys, we're doing a very simple example. We're doing an example of something that every one of you has done, I would say, at least 3, 4, 5,000 times in your life, which is walk into a store and buy a product. If I gave you an example of modeling a warehouse, and the warehouse has shelves, and each shelf has bins, and each bin can hold a type of product, and each product has a SKU number, and we have a entity called a warehouse clerk, and the warehouse clerk has another entity called a packing order, actually a picking order and a packing order, and the warehouse manager, which is another entity, gives a warehouse clerk a picking order and a packing order, and they are aggregates of product location and product description. And we also have a purchase order. I'm talking about supply chain management stuff now. And the purchase order relates a customer order to an account number. And if I were to ask you to model all of that, that would be hard, especially since most of you have probably never worked in a supply chain management situation before. Do not tell me this is hard, because I know. Parth, I know that you've gone into a store and you bought stuff. Maybe you did yesterday. Maybe you're going to go again today. So this should be very familiar. This is not a confusing business domain. So a product has a price and needs a payment. And by the way, guys, and ladies, if you follow along with me, I know it might seem a little bit tedious and painstaking, but if you go to law school, this would be your life. For 4 years, you would be arguing and writing papers and doing practice trials, arguing about the most obscure and subtle meanings of words. And the best lawyers are the best lawyers because they can take a common word and they can show the judge that it has some other meaning, and then the defendant says, well, I didn't mean it like that, and the other lawyer says, well, it doesn't matter what you meant, that's what you said. I'm trying to think. There was one example I heard a few years ago that really illustrated this well. Oh yeah, it was in some political thing, right, a couple of years, don't ask me why, but I was watching CPAN, which is the Cable Public Access Network, and they show these things from United States Congress political situation, and there was this senator who was in trouble, right? He was being interviewed by an appropriations committee because they said he had spent too much money on some personal things or something. So the prosecutor asked him, Senator, is it your sworn testimony that these receipts you presented for your purchases are legitimate, they're valid? And the guy gave such a brilliant answer that the judge of the proceeding said, okay, you can go. He let him off just because of the nature of his answer. The defendant said, that depends on what your definition of the word is. Think about that for a while. The point of my story is that if you're happy to be somebody who makes $15 an hour running a cash register at Walmart, and there's nothing wrong with that, but if you want to elevate yourself to the higher levels of being a professional person, this kind of thinking is going to be what gets you there, right? And if you do not know that there is a whole grammar and a logic behind business analysis, when you go to work and you're a programmer and you're sitting in a meeting, you're going to think, Jesus, they're talking about stupid bullshit. But if you now have the understanding of the world that quote-unquote stupid bullshit is actually the basis of how we construct the technology that our civilization is running on, then you can make the decision to get good at that alchemy, and you can get into those jobs yourself. So with that little bit of encouragement, let's go back and look at this again. So we started out with a fairly simple challenge, which is to construct a lexical analysis of our use cases. They're not my use cases, they're our use cases. I'm sharing them with everybody. They belong to you the same as they belong to me. So we have nouns and we have attributes which give more details of those nouns. and we have verbs, which are actions. So payment is a noun, and then attributes, kind of payment, amount of payment. And we have a product, and similarly, a product can have some attributes. And by the way, I don't expect you to do this perfectly for your project presentation. And we're not going to finish it today. We're going to finish it tomorrow. I mean, we even have Wednesday as well, because we don't really have any more new content to bring into this class, by the way. The UML product architecture is the last thing, and that's the hardest thing. But we have time for it. I expect you to at least make an attempt to show me you're starting to get your thinking going along these lines. Oh, I'm going to forget about this. Even though I think some of these people might not be here, but we'll hope that they are. What do I have in my analysis domain? Maybe that question will help you think about this. I have payment, product, and customer. And here's the thing I was drilling to before you guys didn't answer me. I have a transaction. A transaction is a thing. It's an intangible thing. It's not a thing you can pick up, but it is a thing I need to model. And a transaction models the connection, the relationship between a customer and a payment occurrence. And a product and the store. Well, what exactly is the store? We're modeling the cash register as the store. And some other things that we could include here would be the date, time, maybe the name of the clerk who did the transaction, maybe some other things. Those are the big ones that occurs to me right now. Now, is there any other stuff? Well, here in terms of product, I'll keep it simple. There could be dozens of things for a product, but I will call it product name. So that could be like purse, wallet, whatever. Maybe color, stock number, SKU number, which is location on shelf, size. I guess if it's a jacket, it could be big or small or something. And then I don't think we'll get to this till tomorrow, but I do expect you, and I hope at least in your subconscious brain you'll think about it. Tomorrow we're going to actually make our UML, and then we will forward generate. And just to keep it simple, I will do the example of forward generating into Java, because that's pretty fast and light and simple, but you could do it into Swift or any other object-oriented language you have handy. So I have a payment, a product, a customer, and again, a customer has a name, and maybe they give us their cell phone number. I mean, you could ask for other stuff, but they probably don't want to tell you their address and stuff. They're going to say, well, none of your business, I'm not telling you. But they would have a bunch of details there. And then how do we relate a customer to a payment? Well, a customer has a payment method. And we're going to see, and because you guys have an advantage, because you're programmers, So you already know what it means when I say there are two ways to link objects in object-oriented, by inheritance and by composition. And here we're going to do it by composition. We're going to give our customer class or object a field attribute of type payment, and that will do a compositional linking between a payment and a customer. Sometimes I teach this as business analysis to business students with no programming, and it's harder for them to make that connection. But I hope you guys are now quickly converging your thinking on understanding that the purpose of this is to give us a methodology of ensuring that we capture every aspect of our domain and we capture all of the details, and then tomorrow we'll make UML entities and see how we relate them. So we've got a couple of minutes left, so let's see what else we can get to here. So product, a customer, a transaction. Once again, that's going to be an object, and it will have fields of type customer, payment, product, and store. Well, why are we putting the store in there? Because we need stuff we cannot easily get to otherwise. And by the way, this is like theater, right? This is not really like a technology like fixing a diesel engine or something. It's not very procedural. If you have any kind of a sensibility of writing a play, if any of you have ever done creative writing or you've written a theater play or something, sometimes you make a character say something because in the next scene you want another character to remind them and say, oh, Sir Horatio, you said so-and-so. So this is like writing a script for a movie. We put things in because we're going to need them later. Now, we know when we get a receipt, by the way, that is another construct here in our business domain, a receipt. We have to put that in there somewhere. And a receipt is just a record of a transaction. And what does the receipt want to have? The payment amount and type probably, maybe the credit card number or something. Actually, we can just say payment because then we can get to all those other things. Maybe the sales clerk's name, sometimes they put that there. The date, time, because if you're going to return it, maybe you have 14 days to return it or something. Now, instead of putting all this stuff, if I just put an object here called the cash register or the store, or the transaction details. Actually, I could just put the transaction here because then I would have all of this stuff. Yes, I'm going to do that. Transaction. Yeah, all I need is the transaction object. That's my receipt because the transaction knows everything else. And can anybody think of anything I've forgotten? I have payment, product, customer, transaction, receipt, which I'm modeling separately, even though receipt is just a record of the transaction. Actually, maybe I should make receipt an attribute of transaction, since it doesn't really have anything else going on for it except for that. Now I go over here and scan over my use cases and my user requirements. Oh, data store. What about that? Yeah, my data store is an actor. Now, some specific design patterns come into play when we're talking about our data, our persistence layer, because we know that in model view controller, the model is a object which is a mediator to the data store. And I'm not going to go deeply into that beyond saying that even though we generally don't model actors as UML entities, we break that rule where the actor is a data store, because the data store has a very unique, it has a very special role in our IT system. And it just happens we do it that way because we have to. If we didn't, we wouldn't have any other way to do it. And if you're not sure what I'm talking about, tomorrow when we do the rollout, when we construct UML entities from all of our words that we identified from our lexical analysis, I'll put it together and you'll see why that is. So nouns: payment, product, customer, transaction. And transaction's going to have an attribute called store. I suppose I should also put this, yeah, I'm going to put these things separately. So I'm going to have date, time, and name of sales clerk as separate attributes of my transaction class. And I know I said point of sale terminal over here, but I'm actually going to ditch that. I don't think I need to have that as a separate thing. I'm just going to let the cash register be in charge of both these things. See, because this is a fluid thing. We move it around as we're thinking about the best way to do it. So data store, cash register. Yes, that's an entity I need to model. Cash register. Is the cash register the same as the transaction? By the way, when you present for your team on Thursday or Friday, I will ask you questions like that. I will look at your architectural diagram. I'll say, is A the same as B? And I think we're out of time. I have time. It's 12 o'clock. Just give me one more minute. So my answer here is cash register and transaction should be two separate entities. Why? Because they have different responsibilities. One heuristic. Heuristic is a thinking rule. In fact, we have about 6 thinking rules we need to cover. So heuristics, how to decide what should be an entity that we model. And we'll see some examples of there, but a good general rule is if it has some unique purpose or job that it's doing in our business domain. Now you know why we say that you have to be an expert in the business domain you're working in. Because if you were to go and work in the healthcare sector and you're trying to model things like medicines being dispensed out of the pharmacy or something, if you're not familiar with those terms or what people are actually doing when they do that, I think that would be quite difficult. So anyway, it's 12 o'clock. I know you guys have another class. So I'm going to wrap up this video and kick it out with some extra comments as well. And please watch that video before class tomorrow. And it is now noon. It's 12:02. So class dismissed. See you guys tomorrow. Watch my video when I send it out. Bye.